Welcome back. We're going to close out this chapter here with a discussion of research methods. There are four ways that human beings know things. The first is we rely on our intuition, our gut feelings. Intuition is that way that you immediately know something to be true or false, without even thinking about it. Just what your gut says. If I say men are different than women, intuition, you know that to be true because your gut says, well, yeah, of course they are. When intuition gives us an answer, whether it's right or wrong, it's directly linked with our emotions. So that's why when you're having an argument with somebody who just knows something to be true based on their intuition, they hold fast. They're not going to change their mind very easily because their emotions say this is true as well. Sometimes we're wrong. Sometimes our intuition doesn't know the answer, and that's when we're going to sit and ponder things for a while. When we do that, we're using rationalism. We're trying to use logic and reason to figure out a rational understanding of a certain concept. Sometimes we don't have all the information we need, and therefore we're going to Google something, or we're going to go to a certain authority, a teacher, a preacher, any of those sources that give us answers. When you appeal to Google, you are appealing to authority. You're looking for someone that knows the answer, that has more reason to know the answer, so we're looking for experts. It used to be just the philosophers were the experts, and you would base what you know to be true on either what you can rationally understand or on what somebody like Socrates says. Nowadays we go to our parents or preachers or teachers or books or Google or Wikipedia, and we use those as authority. One interesting idea, though, to note is that if you go to Google anything, you're going to find many, sometimes millions of different responses, and those differ. Sometimes you'll get completely different answers from two authorities that you respect, and that's when empiricism comes in handy. Empiricism means that I take my question and I apply the scientific method to empirically back up my answer. I'm going to do research. The wheel of research looks like this. It begins with observation. I observe something and I'm not sure why it happens. I have a pretty good idea because each of us has our own personal theories for why people do the things they do, why things happen. But sometimes those theories aren't enough to explain the observations that I'm making. And so then if I'm a research scientist, based on my observation and the holes in my theory, I want to fill in those holes and I want to form a hypothesis. My hypothesis is my best guess, an educated guess about why that X, Y, and Z is happening. A hypothesis is positively stated, and it's a statement, it's my research thesis statement. I believe that if I put 50 kids in a room and let them play a violent video game and then give them a chance to duplicate some of that violence, that the kids who play the violent video game will be more violent than kids who play a passive video game. That's a hypothesis, and it guides my experimentation. I figure out which video game I want to use with games, the passive and the violent. I run each kid through a 30-minute session with that video game, and then I also need to figure out how I'm going to present them with an opportunity to duplicate that violent behavior. Maybe a room filled with toys, some aggressive and some not, behind a one-way mirror so that I can see in but they can't see out, so they can't know that I'm watching. Then I'm going to figure out a way to measure their level of violence. How many aggressive actions do they take towards a punching bag, for example? I count all those up, and those will represent the results. In that particular research study, I'm bringing people into a situation and creating data. They haven't hit the punching bag until I bring them in and run them through my experiment, and therefore I'm forming what's actually called experimental research. So if you look at the orange branch, in experimental research, I have to run an experiment. I do something to a group of subjects. And because experimental research is creating something, I need to know what would happen if I hadn't run another group of people through that same experiment, having them play a violent video game. So I have my experimental group, which plays the violent video game, and then I have a control group. The control group is treated exactly like the experimental group. The kids who play the passive video game are still sent into the room with the punching bag, but they didn't watch the violent video game. In fact, they played a passive video game. That way I have a comparison. I can count the number of aggressive actions my experimental group took, and I can compare that with how many the control group took. And if the difference is significant, I can say, based on my experimental data, when children play violent video games, they'll behave more aggressively. Two other things. Experimental research is rigorously controlled. You control for variance. You control for variance is anything that causes variance or variation in my outcomes. So I'm not going to let some kids listen to violent music on their headphones while they play the violent video game, and some kids not. We also have variables within an experiment. A variable is anything that varies, anything that changes in number or intensity, the number of violent actions taken, the type of video game that the people played. In an experiment, you have an independent variable and a dependent variable. The independent variable stands alone. It's what you do to your subjects. It's the conditions that you run them through. It's giving them the drug so that you can see what the results are. It's letting them play the violent video game to see how violent they behave. It's independent. The dependent variable can't stand alone because it's the results of what you did. It's the number. It's the improvement in the person who took the drug's depression symptoms. It's the number of violent actions taken by each group of subjects. So it's dependent upon the independent variable. The dependent variable comes second in your description, and it all depends on the independent variable. In some situations, we're going to look at the green branch. Data's already out there. You don't need to bring subjects into a laboratory to create the conditions to see their reactions. You have plenty of reactions that go on all day out there. This can be valuable in situations where to run the experiment would be unethical. If I want to know about the effect of parents' divorce on their children's future romantic relationships, well, I'm not going to pay parents to divorce and then follow those kids watching the quality of their relationships and waiting until they break up. I'm going to gather a group of individuals whose parents may or may not have divorced and ask them about their relationships. One of the questions I would have on my survey would be, how old were you when your parents divorced? Another question I would have on that same survey would be, considering the quality of your romantic relationships, how would you rate them from 0 to 10? Then I've collected data, I've collected reality that's already out there in a non-invasive, non-damaging way, and I'm going to describe that data in an organized fashion. That's why it's called descriptive research. You go collect the data and you describe it in a way that makes sense. One form of descriptive research is a case study, observing one individual, one case in detail, and describing that with theories that already exist. I mentioned survey research. Most of us have taken surveys online. Who are you going to vote for? How do you feel about this situation? That's a great way to collect data. And then if I had 100 people polled with a survey, I could categorize all of that polling data into what's called a correlation design. Sometimes psychological testing is used in descriptive research as well. Correlation design is one of the best ways to use descriptive data, and that's to basically compare one piece of data with another piece of data. So I compare X with Y. Age at which the child's parents divorced, versus the quality of their romantic relationships. In experimental research, I'm looking for cause and effect. In correlation research, I'm looking for some kind of relationship between two variables. And I'm going to go down here and see if I can find... Okay, I can't find it, but that's okay. Correlation data is usually on an XY graph with one variable going up the x-axis and one variable going along the y-axis, and you set them up and you look for a relationship between those two variables. Even if you find a strong relationship, a positive relationship, let's use number of hours studied per day with overall GPA. We would assume that as the number of hours of study per day go up, overall GPA would go up as well. That's called a positive correlation. As one variable rises, the other variable rises as well. Well, those two variables don't have a causal relationship. Studying doesn't cause me to get good grades, as any of you might have experienced before. You study for forever and then make a poor grade in the exam. And certainly overall GPA doesn't cause me to study for long hours. There's a hidden variable in there. People who study for long hours usually have a strong work ethic, a desire for success, a strong motive behind their education, which tends to impact their GPA as well. So in correlation design, we don't say anything causes anything else. We say they're related positively, and therefore it gives predictive validity. I'll write that down. Correlations provide predictive possibilities. The stronger my positive relationships, the more likely it is that I could go and say, Janie studies for 4 hours a day. Her GPA is going to be better than somebody who studies 30 minutes a day by the end of the year. That's the prediction that you could possibly make. You could also go the other way. Bob, who has a 4.0 GPA, probably studied for many hours during the week versus somebody who has a relatively low GPA. You might be able to predict that they studied very few hours per week. I'm going to stop there and pick up with actually, we're good there. That's good. That's a basic understanding. So the two types of research in psychology that we talk about are experimental research and descriptive research. And the next video audio you hear will be me talking about Chapter 2. Thanks.